on 8.6, which is geometric sequences, and we'll be able to form geometric sequences and use a formula to describe geometric sequences as well. To start off today, let's talk about what a sequence is. A sequence is considered a number pattern. So here we have a number pattern, here we have a number pattern, and we are trying to find that. And each one of these numbers is considered a term in the sequence or number pattern. Also, what we're looking for, this common ratio, is that number, or what is happening from each term to term. What common thing is happening between them. So let's take a look. Here they have just widened out our numbers: 3, -15, 75, -375. And what we're doing here is we're timesing by a -5 to all of them. So 3 times -5 gives you -15. -15 times -5 gives you 75. 75 times -5 gives you -375. So the common ratio, which is what we're looking for. So what is common amongst all of these? The fact that it's being multiplied by a -5. Once again, what is happening between 3 and 3/2, or 1/2? 3/4, 3/8. What's happening? Well, we are multiplying by 1/2. So this is the piece that you guys are trying to find. Now, you have done this in previous classes. However, things are just going to continuously get a little tougher, a little more challenging. So once again, they're timesing by 1/2. So that is going to be our common ratio. That is what is common in all of them. By the next 3 terms of the sequence. So instead of just finding the common ratio, now they're asking you to find the next 3 terms. The same process is going to happen. So the first thing we need to do is find that common ratio. So even though that's not what it's asking, that's what we are looking for. So 5 times -2 gives you a -10. -10 times -2 is going to give you a +20. 20 times -2 is going to give you -40. So my common ratio here is we are timesing each term of the sequence by a -2. So it's asking find the next 3 terms. So I need to find the next 3 terms. So we're going to take -40 times -2 is going to give you a +80. Alright, so we had times by -2. The next thing, 80 times -2. We're going to get -160. 160 times -2 is going to give us a +320. So my next 3 terms are 80, -160, and 320. The next part is determining whether the sequence number pattern is arithmetic or geometric. Okay, so when there's a common difference is going to mean arithmetic. So if you're adding or subtracting between each term, you're going to label it as an arithmetic sequence. However, if you're multiplying by 1/2 or multiplying by a whole number, you can also think, instead of multiplying by 1/2, maybe dividing by a number. Multiplying, dividing, it's going to be considered geometric. So let's take a look. Between 62, 54, 18, and 6, what's happening? Well, they're timesing by 1/3. You might be asking, well, how do I get this number? How do I know this is the common ratio? And this is where your math skills have to come in. You know you're getting smaller, so we have to be multiplying by a fraction or subtracting. If you're not subtracting by the same concept, look for a fraction you can multiply to get these numbers. Okay? If fractions are tough for you, think this way. 3 times 6, 18 times 3, 54 times 3. And like I said, so instead of dividing, we're going to be timesing by the fraction piece. So now that we know that we are multiplying, we know multiplying by 1/3 for between each term. It has a common ratio, so the sequence is geometric. Another example. What's happening? Well, we are adding 3 to each one of these terms. So, since there is a common ratio, and it is addition, it's considered the sequence is arithmetic. You can label it as an arithmetic sequence. The last piece for today is going to be putting information into a geometric sequence. And the first thing is we are going to use this equation. Now, it's important to know what these variables stand for. Okay, so this is also in your book on page 462 if you do need a reference again and you can't get back to this video. But the nth term is going to be what we are looking for. A is going to be the very first term in your sequence. The common ratio is what we have been working on so far. So what is happening between each term, and your term number is going to be the same thing here, is what you're looking for. Okay, that's going to be your n value. So let's jump into it. We're going to use this a times r to the n minus 1 power in solving our next equations. So I'm going to write up here, even though we already know it, a to the n equals a times r to the n minus 1. So they have graciously given you the equation already. And all you're looking to do here is to find the first, 5th, and 10th term of the sequence. So that is what we're looking for. What the first term, the 5th term, and the 10th term are in this sequence. So we're plugging the first term, we're plugging 1 in for n. So a to the n. So here we go. We plug in our 1 here. 1 minus 1 is 0. 2 to the 0 is 1. Negative 3 times 1 is negative 3. So I know the first term in this sequence is negative 3. Next, we're finding the 5th term. So here, since it's the 5th term of the sequence, n is going to equal 5. So we just plug in a 5 wherever we see an n, which we know it's n minus 1 here. And then this is my n value, which is 5. Plug it in. 2 to the 4th, 16. Negative 3 times 16 gives you negative 48. The 10th term. So we are looking for, and that's what our n is, what we're looking for, the 10th. So plug in 10 for your n, and you're going to get negative 1,536. That is all for the note video today.